In 1974, Donald Johansen was exploring the Great Rift Valley in the Afar region of Ethiopia, looking for fossils that would help fill gaps in the human evolution. He discovered the famous Lucy of the species Australopithecus afarensis. Scientists were certain she was bipedal but could not agree on the type. Did she walk fully upright like us or bent knee, bent hips like chimpanzees? She was the only one of her species found and her fossil was incomplete, leading to a lot of uncertainty around her limb proportions and inertial parameters. As a result, there were generally two versions of her in literature, the human-based and the chimpanzee-based version. In 2004, researchers from Loughborough University, University of Nottingham, and the University of Liverpool tackled this problem by building a bipedal gait simulator that predicted the energy cost of both gaits on the two versions of Lucy. The idea was that the preferred gait would be the one that is most energy efficient. The simulator controls a model of the body using three states that tune 7 parameters each. With a total of 21 parameters, it would have taken an eternity to test all possible combinations. So they used genetic algorithms where the parameters were encoded as a list of 21 numbers called a genome. A population of those genomes were randomly generated and each given a fitness score based on how far it traveled given a fixed amount of energy. The next generation was created by crossing over genomes at random influenced by their fitness score. This process was repeated until no better solution was found. The system started with a human model and gradually morphed it, optimizing at each step the parameters received from the previous simulation until the target model was reached. This is known as gait morphing and was used to create the human-based and chimpanzee-based Lucy. Each of these models were again morphed from 0-degree knee flexion like humans to 40 degrees like chimpanzees while capturing the energy costs. Both versions of Lucy had just about the same amount of energy throughout that was smallest at 0-degree knee flexion. This meant that 1. Based purely on locomotor efficiency, Lucy walked upright, and 2. Whether you go with a human-based or chimpanzee-based Lucy, it makes almost no difference in the energy cost. Even more impressive is that a year after this paper was published, an older and more complete fossil of Lucy's species was discovered that confirmed the upright gait. At the time of publishing, the system favored lower speeds, but researchers were curious to see how the model would perform at seemingly less optimal speeds. This would be useful in, for example, a human simulant and allow for a richer comparison with experimental data.